Hi everyone, and welcome to today's Chemistry Daily Booster. This is number 22 in our Paper 2 series. Now, although this isn't explicitly listed on the advanced information, we do know from previous experience that that doesn't mean there won't be questions on it. So still worth going over this just to make sure that you do understand it, because it might be the difference between one grade and another for you. What we're going to do then is have a look at how we actually make water suitable for drinking. So, first thing, where does tap water come from originally? Before it ends up in our taps and the pipes that lead to them, then it will come from lakes, reservoirs, aquifers, rivers, and even wastewater. That has been a nice easy question in the past where they're just literally asking you a one marker, where does tap water originally come from? Any of those gets you the mark there. However, we can't literally just go down to our local lake, stick a glass in it and then have a nice drink, because there are going to be a range of possible contaminants in there. Things like soil and leaves that are insoluble. There'll be the soluble substances like salts and pollutants that are dissolved within the water itself that we can't see. And then there are microorganisms that can cause a wonderful range of diseases you really don't want to get. We've got basically 4 stages to this process we need to remember. Filtration, to remove the large objects like the sticks, etc. Sedimentation, where any of the soil and smaller particles are going to sink down to the bottom. Filtration, to remove anything small that still remains. And then finally, chlorination, which kills any bacteria present. So this is just a little diagram showing us what actually happens then. Here's our reservoir, where our water is going to start off then. Now that's where we just store all of the water before we're actually going to send it through the processing. So the first thing that happens is as the water leaves the reservoir, then it enters the water treatment works and it's going to have our initial filtration stage. So you can see we've got these basically mesh sort of screens that are going to just filter off any of the larger objects, twigs, leaves, etc., and stop them going any further. The water then continues into the first tank, which is the settlement tank. So at this point, the water sits in this tank and any of these particles that are floating around in there are going to sink to the bottom as this stuff called sediment. Hence, we have our settlement tank. It sinks to the bottom as the water settles. We then run that water out, leaving behind the bits of sand and soil, and we're going to add a stuff called aluminium sulfate and lime. So 2 different chemicals added to this water. Purpose behind that is it makes some of these smaller particles like bits of clay, etc., stick together and then they sink to the bottom, because on their own they're too light, they'll just keep floating. By adding the aluminium sulfate and the lime, they stick together and sink to the bottom. We then allow the water to continue on to our next tank, and we've got a very fine filter basically. Very fine sand, etc., that means that as the water trickles through, it's going to remove any of those remaining particles of mud, grit, etc. So in theory, our water now is lovely and clear, but there could still be things like bacteria present. Due to that, what we now do is we're actually going to add a small amount of chlorine to the water. That kills the bacteria, and then we double check what's coming out the other side, making sure the pH is correct, so it's neutral, making sure that there are no kind of excessive dissolved chemicals, because remember, dissolved substances will not be removed by any of those processes. So if there are any large amounts of certain chemicals, we then need to do something else. We can't just let that water go if it's got high levels of a dangerous chemical. Assuming all is fine, it continues on and ends up in the taps in our homes and businesses. We do have another option available to us, which is using the seawater that surrounds a large number of countries. Now, we can't obviously just drink salt water because that is again terrible for your health because of the large number of dissolved salts present there. If you were to drink it, it would mess with the osmotic balance in your body and it would not end well. What we do is we carry out this process of desalination. So basically desalination removes the salts to make the water potable, i.e. drinking. Now we can use 2 different versions of this. Small scale desalination, that uses reverse osmosis by ultrafilters to get those salts out by filtration. Or if we're talking on a much larger scale, then we use simple distillation to achieve it. So that is the end of chemistry. We are going to have a live stream tomorrow, Sunday the 19th of June at 6 p.m. on the channel. So we'll run through everything for the Paper 2 chemistry at that point in time, hopefully just to settle any nerves that you've got prior to the exam. Of course, if there are things from today's booster that you want to look at in a bit more detail, then you'll find the video in the C6 playlist on the main channel. You've also got your revision guides to use, and of course don't forget to look at some past exam papers to get a bit of a feel before that real paper on the Monday.